And now again I go back to debug and stop debugging, so that I don't really have to continue this debugging session. And logical instructions or bitwise tests are all familiar, and or, exclusive or, and not. So for example, we could try to use them as, for instance, not. Not will invert every bit in a register. So for instance, not EAX. Okay, so not EAX, we will try to see what this does. I'm moving my breakpoint here, so we'll try to observe what this does. Then we can try to AND EAX with some kind of value, like for instance, we can AND it with 1. Okay, just like that, with like 1-bit value mask. We can try to do that. And then we will also try in this test right here, test, and we'll try to do the same thing. Rather, I will rearrange them like that. So we'll walk through this code and we'll discuss what is happening here. Okay, so we have a few examples of these logical instructions, and so let's give this a try. I'm just going to rebuild, and I already have the breakpoint, so I'm just pressing debug session to start debugging again. So this is where we stand right now. So register EAX contains hexadecimal 8. So I think that hexadecimal 8, if you think about it, the binary form of hexadecimal 8 would be 1000. Okay, so this is binary 8. But of course we have plenty of zeros in front of this because this is like 8. I mean, sorry, it's 4 bytes. Okay, so we have this is how the binary equivalent of this value would look like if we try to write it down. Okay, so it's like this. And you can see that in this 32-bit binary number, only 1 bit is set. But I'm saying not, which will flip every bit in this value. So when we step over, debug, press F10 or step over. Apparently I was in the middle of like making some changes, so let's just stop and rerun it. Apparently when I was editing it, obviously the Visual Studio knew that I was doing it. So I'll just rebuild and debug, start debugging, and now we'll step over this by pressing F10, or you can say right here on the menu, debug menu, step over. Okay, so there it is. It all changed to F and 7, so it should not be very difficult to envision this value. Is like now it all so each F corresponds to 4 ones, just like this, 1 1 1 1, and now we can obviously replace every F with 1. So of course this is the result of not, like this, and here it's a 0 and 1 1 1 at the end, and this is still 1 1 1 1, like this. So of course this is binary 7. You can see that the not instruction flips all bits like this. And once again, it's probably going to ask me if I'm going to rebuild the program. So this test instruction will take this value, which would look like this. Of course, it will be all zeros, all zeros, all zeros, and here all zeros and 1. Okay, so So we have register EAX that contains this type of bit pattern, and hard-coded value 1, which in 32-bit equivalent has this type of representation. And test instruction does binary AND. Okay, so as a result of it, all of these bits above the lowest bit are set to 0. So ending with 0 should result in all ones, and only this will be used as a 1. However, when we execute test, notice what's going to happen to flags. I'm doing this test, and I will say ignore and do it. Okay. So it updated, well, it kind of updated this code. So I'll just redo it one more time. Debug, stop debugging. My editing the code kind of gets in the way. So one more time, we just press F5 to start debugging session, and make a stop right here, F10 to step over, and once again just watch what is going to happen when we apply this bit pattern to the value in EAX, right? So EAX stays unchanged, but the flags are being updated. So the flags are being updated due to like greater than, less than, equality, inequality. All sorts of flags are set because of this. And this is referred to as non-destructive AND instruction. So it does the same as bitwise AND, but it does not change EAX. On the other hand, if now I compare it with AND instruction and I step over this one, it actually does apply the mask, does the same updates in the flag right there, but also changes the destination. So now EAX was changed to this. Of course, the result of applying this mask would be just this bit set at the very low portion of EAX. So these are called logical instructions, and you can see that they're heavily correspond to bitwise manipulations. They're all bitwise logical expression. Bitwise means that regardless of the size of the data, all logic is applied to individual bits like this. So all of these instructions apply AND, or, exclusive or flipping the bit, just in a bit by bit manner. Okay, so there's no any kind of arithmetic happening, only the top and the bottom bits are being processed like this. So it's bit by bit process, and then the outcome is just the whole result right here. And the test instruction is exactly the same as this, except that it does not change its destination. It's only comparing them, like using the bitwise comparisons, and instead updates the flag register with the results of this test. So test can be used similar to compare instruction. Once again, when we do our discuss control flow in assembly, we will use examples of test and compare in more of a logical context, rather than just throwing in some kind of examples out of the blue, just like writing these random instructions and discussing their formats and what their inputs and outputs become. So let's also stop this debugging session. We've seen these examples right here, and of course, just like an AND, we can use OR, exclusive OR, and so forth.